There you go. How about now? Is it okay now? Okay. All right. Thanks. Anytime, yes. Marcy, I can see you. Okay, Patrick, can see. Cornell, can you hear me? Jamal, you can hear me? Good. Yeah, Susan, Tess, good. All right. Thank you. All right, Alex. Yeah.
Yeah,
Okay,
I
I'm
think
glad.
judging by the trend, everybody's okay.
Yeah, yeah. So, yeah, greetings, everyone. I'm glad to be with you this evening, and we have a guest. I think we had introduced Kelvin. Yeah, so Kelvin, I've known him for about 3 years now. He went to study in Germany, and then he has a bit of experience in the area of insurance, in creating models and how data science is impacting that. So he was kind enough to agree to run for us a series on how you're able to uh, resonate what you're studying in class with the industry application. So I would like to introduce Kelvin, and in his webinar today, he'll be taking you through machine learning applications in the work, especially in marketing. And without taking much of what he's going to do, Kelvin, I'd like to invite you to come on board and please share your experiences, tools, and what you have prepared for us today. Feel free to engage. Yeah. So yeah, the floor is yours.
Yeah. Okay. Thanks, Tim. I hope everyone can hear me. So yes. So as you've been told, my name is Kelvin. I've worked in Kenya for like about 6 years as an actuary, and now I'm just finalizing my master's studies in Germany on data science. And I've been in the field of data science for about 3 years now. So I know a few things here and there. So hopefully I can be able to share some with you. So how Tim approached me and he explained to me that you have a series, and so he allocated a three-part series for me. So how I thought best to go about this is to kind of give you an introduction to the application side of machine learning and data science, which is what I'm scheduling for today. And then for the next two remaining sessions, we can go a bit deeper into the things that I will show you today, depending on also the feedback that you will have. So maybe after this, you can kind of indicate your areas of interest, and then we can go deeper depending on which one is chosen by the majority. So we take a democratic approach to this. So without much further ado, I will start. So I hope you're able to see the presentation as well. How do we do this? Okay, so are you able to see the presentation? You can just, a few people can type yes or no. Brilliant. I think we can learn from the data, so I'll not wait for everybody's response. Okay, so we begin with just an overview of what we'll be looking at today. So we'll have a small introduction. I'm sure you've already been introduced to data science and machine learning, but we will just brush over it a bit. And then we will look at the categories of learning, and then also just look at the learning process a little bit, because all these things will come into play when you're actually doing your models. And then we look at the use cases. Specifically for the use cases, we look at how do we use this stuff to upsell, to cross-sell, to prevent churn, and to make our call centers better or more efficient. So we get started with the introduction. So just some definitions, which I'm sure by now you're already familiar with. So you have basically machine learning is trying to use algorithms that can learn from data. And statistical learning is basically a branch of applied statistics that emerged in response to machine learning. So when machine learning became quite a hype, the statisticians did not want to be left behind. And so they came up with a branch of statistical learning, but this one emphasizes mostly on statistical models. So not just because, yeah, machine learning is not statistics per se, but it isn't, yeah, but it's statistics. So it's a bit confusing. But then all these things combined together kind of come into what you know, or what you've come to know as data science, which is basically just extracting knowledge from data using different ideas from maths, statistics, machine learning, computer science, engineering, etc. So finance, marketing. So yeah, it also depends on domain, the particular domain for which we want to apply these things in. So all of them are very similar, with subtle differences here and there. So the main thing that we'll be looking at is what you call supervised learning. So maybe you've already heard of this. What that means is that you have some training data, which has different attributes, and then you have a response, right? So the other type of learning is unsupervised, where you just have the input data, but you don't have a response. But in our case, we have both input and a response. And what you're trying to do is fit a learning algorithm to it, and then use that final output to make predictions. Yeah. So just a brief history. This thing, it's not a new field. I mean, statisticians have been doing this for years. But the difference now is that what the statisticians used to do is they had to be domain experts in their fields, and then they had to work for very long periods of time to kind of be able to learn proper features that they can use to make predictions. So what this meant is that they were able to do these things in very small data sets. Yeah. But now in the advent of big data, as everybody keeps calling it, we don't need to be domain experts per se. Like, it's good to have domain knowledge, but you don't necessarily, it's not a mandatory thing, because what you have is just you get large data sets, and then you look at what we mean by these large data sets with many features, and then now you use your algorithm to find the good ones. So instead of taking 10 years learning what features are best for certain prediction, you can just throw all the features in, and your machine learning algorithm will find the good ones. So this has been the huge change. And just as a note, in your learning process, you need to understand one thing. The thing that is critical in machine learning, especially if you're going to use it for business case, is model validation. So it is very important that you once you train your model, you should test it on data that you have not seen before. The reason for this is that you want your model to be able to perform well in your use cases. Yeah. And so if you train it and you test it on data that it has already seen before, then you have no confidence, or you have very little confidence that it will actually work well in your use case. So it is very important. Let nobody ever lie to you that you have a wonderful machine learning algorithm when you have not seen the careful internal validation of this particular algorithm. Okay. So what types of big data do we have? So big data can be defined in two, or I define them in two. You have those ones which you call the wide data. So what this means is that you have hundreds of samples, but then you have thousands or millions of variables. I mean, anybody who's worked in what do you call it, the area, the field of web development, you know that when you collect data, or when you're talking about cookies, it can come into millions of variables. It can result into millions and millions of variables. And so there are various ways to deal with this kind of data, this wide data, where you have to, you have many variables and you need to get rid of some of them. And that's why you tend to use things like what you come to know as a lasso regression and L1 type of, what do you call it, regularizers, yeah? But you will be aware of this with time. And then the other type is a tall data. So not very many variables, but they have thousands and millions of samples. So the ones that hang your computers. So these are the more common types, as you probably, especially if it comes from your CRMs or your business systems, basically. Yeah. So how do we deal with this kind of data? Um, the various ways in which you can handle this type of data when you're working with it. You can do some sampling, so you don't have to take everything into account. Or if you have a good understanding of computer science, you can apply MapReduce type of things to work with this big data. Or you just find a job at Google because they have all the machinery to be able to handle all this kind of data. So join Google or Facebook and work for them, and you will not have problems with big data. So next we look at the categories of learning. So you have different types of learning. You have things, and I am broadly classifying them here. Yeah? So there may be others, but broadly classified, you have clustering, where you can use, basically you're trying to look for groups. Yeah. So this is good, especially when you're looking at things like target. You want to identify your target markets. You want to identify similarities. So you have your group of customers, because I understand most of you are coming from the insurance background. So you have your customer data, and you're trying to figure out what groups exist within these customers, and so that you can go to the next question of how do I exploit this. And then the second one is regression. Now this is basically when you're trying to predict a continuous variable. So you're trying to predict what the temperatures will be like tomorrow. You're trying to predict how much will your customer spend on certain products, how much are they likely to do, this type of predictions. And then you have the third one, which is classification, where you're grouping things into categories. So you have binary, where you're saying you either belong in group A or you belong in group B. And you have multi-class, where you're saying you can belong in any group. So basically things like object detection, when you're given a picture, it can be a picture of, there can be a dog in the picture, there can be a cat in the picture, there can be a car in the picture. So all these are groups for which your model wants to classify the object that it has seen in that particular photo. And then the last one, in my case, is what you call recommend assistance, so recommendation, where basically you're trying to see, should we propose a product A to customer X, or what is the likelihood of them purchasing given that you propose this kind of product. So all these things are very useful, especially in the use cases that you will come to see, because basically it ends up taking into account all these four different, or you end up using all these four different kind of models to come up with solutions. So, and you have two different types of learning. So there's what you call shallow learning, and there's what you call deep learning. I'm sure you've heard about deep learning being thrown about quite often. So shallow learning basically involves you as the analyst trying to extract features from your data. So if you heard about feature engineering, so you're really the person who's doing the feature engineering, you're doing the extraction, you're going to add new features, you're going to get rid of other features, you're going to change some features in different forms. And then from there, once you've done a lot of feature engineering, then you apply your algorithms, such as the ones we're going to probably have already discussed, or you're going to discuss, such as the SVMs, that's the support vector machines, your logistic regressions, your decision trees, and your random forests, and all this type of stuff. Yeah. So that's what we call as shallow learning. And then the second one is what you call deep learning. This is the neural networks. I'm sure you've heard this term being thrown around quite a bit. Now, how is this different from the other one? Now, the neural network, basically, like deep learning, is good for areas where it's very difficult to extract features. So, for instance, when you have photos, photos, the features are basically like your data from the photos will be just your pixel numbers. Yeah. So, you just have a row of pixel numbers for each picture. Or if you look at text data, you just have words, yeah, or tokens. So it's very difficult to extract features from this type of things. Even things like frequencies or voice, it's very difficult to manually extract features from these type of things. So that's when deep learning comes into play. And it enables you, like when you use neural network, It's kind of like you're using different layers. So each of the layers is trying to model a feature out of your data that is featureless. Yeah. So this is where they perform very well. But they only perform very well when you have a lot of data. So if you don't have a lot of data, and I usually say about maybe 500,000 or maybe a million would be better. If you have less than a million, do not even dare go near a neural network because that's going to disappoint you very badly. So they perform well when you have very good data, like a lot of data. Yeah. So many pictures, many voice samples, many texts, and this type of things. Yeah. So we quickly look at the learning process before we almost getting into our use cases. So I hope I'm not boring people because it's not possible to see feedback and to see your faces. So I hope I'm still still have you. So quickly, the learning process when you're training the data, basically we get data from different sources, and then you pre-process your data. Yeah. So getting rid of things like NAs or non-existent stuff, getting rid of empty spaces or filling the empty spaces, and this kind of things. Tim will the coach will take you through, I'm sure, when you're doing your practicals. And then once we have our data, then we run it through different learning algorithms, and then we test, we validate. Remember, I told you that model validation is key. So we need to validate with each learning algorithm and end up and choose the one that is performing best out of, because there's no free lunch, unfortunately, in machine learning. There's no case that this particular model will always be working better for you. It's case dependent. So usually that's why you will try more than 3 or even 4 different algorithms and just try to validate them and see which one performs better for you. So once we have that, then it's a very iterative process. So you may find that you're not performing very well. So go back to your pre-processing, you come up with new features, and then you test it again, and you find it's still not doing well. So you go back, you look for additional data which you can add onto your data, and then test it until you end up with a good candidate, which you can then deploy, and then your bosses will be very happy and they'll give you a pay raise because you've gotten rid of people, or people are becoming jobless because of you. But hopefully this is not the case. Okay, so I'll skip that one for now. But the other thing I needed to tell you, and you'll probably come to experience this once you start your practicals, is that 90% of your time as a machine learning engineer will be spent in cleaning data. So what you will do is that you'll get data from different sources. You use your CRMs, you use your POS points, you use your billings, your NPS scores, your social media data, you scrape the web, use your emails, call center data, and all this stuff will be messy. I've never come across a clean set of data. If one has come across one, please let me know. So you will do a lot of clearing and just cleaning your data until you have it in a nice structured form. Okay, so 90% of your time you will see will deal with cleaning up your data. So once we have all these things, we've learned the algorithms. So where do we apply them? So we know we've learned of feature engineering and this type of thing. So what are some of the interesting application points? So today, what I'm basically set to look into is areas with regard to customer acquisition and retention. So looking at things like how do we reduce churn from our customer portfolio? How do we upsell in our customer portfolio? How do we cross-sell in our customer portfolio? Okay, so we will start to look into this. And why is this important? Because the idea, if you upsell, if you cross-sell, and if you're able to retain your customers and keep them happy, then of course you have increased sales. So these are things that you're able to achieve. And I'm sure your board or your management will be happy with this type of things. You're able to lower the costs to serve, because if your customers are happy, they will not be calling every now and then. Excuse me. So you will not need a big call center, and you will not have to spend so much in trying to keep them happy. And of course, you have increased customer value. A happy customer is one who's able to happily upsell or cross-sell, so you get more from them. And then definitely all that results in a higher return on investment. So it's a beautiful thing. And this is why, in my experience so far, many management or most management will buy in, especially when you talk about customer analytics. They will buy into it because they can clearly see what the value will be, and it is almost immediate. Yeah. So how do we achieve this? So in the first section, we look at cross-selling and upselling. Yeah. So basically, your idea is to understand which customers buy which product and what the attributes for those particular customers are. And then we look at our portfolio. Yeah. And then from the portfolio, you want to see which are the similar customers to these ones that buy particular products, or these ones that are happy to buy more of the same product. So buying more of the same product is upselling. Buying a different product is cross-selling. So the algorithms that you apply in this case are looking for similarities. Yeah. So like I said, you have your portfolio where you have the people who have bought different products, and then you have the people who have bought more of the same product. You look at the features, what they represent, and then you go to your portfolio and you see which persons are similar in terms of the features. And then and then it gives you a probability score of what is the likelihood of them being able to uptake a certain product, or being able to uptake a cross product, yeah, or another product. So that is the whole idea behind upselling and cross-selling. So basically it will involve you mapping the, I hope you can see my presentation. So it will involve you mapping the journey. So the customer joins you, the customer installs your product if it's a platform, they use your product, they come up with issues, certain issues, either it's resolved or it's not resolved. So there's that journey, and then there's the CRM data, which is the factors, what describes your customer. So this customer is male, he's female, he's age 24, he's aged whatever, his occupation is this, he has a salary range of this. So we combine those two, so the journey and the CRM data about the customer, and then we use what you call similarity scores. So you can, I will I'll dive into the details if you guys will be interested in the next couple of sessions. Okay, so for now it's just an introduction, but I can keep talking on and on and on about this type of things. But so that's the idea of upselling and cross-selling. Yeah. So in a nutshell, you have your clients who already are doing this. Look at the features, look at the journey, then use this to go to your existing portfolio and figure out who are the similar customers. And the more similar they are, the higher the chances of them actually buying into the upsell or the cross-sell. And then those are the people that you spend money targeting. So you throw it to your salespeople and tell them, like, hey, you have a higher chance going to target this guy and this guy and this guy. And then you also throw it to your marketing people and tell them that in your messaging, this should be a messaging for this group, this should be a messaging for this group, and this particular, this diram. So it doesn't end at just showing the clusters and showing the model, but the implementation of it is also quite rigorous, and requires, of course, all your other team members, so your marketing guys, your sales guys, to come into play and to help, but rather to take action on what the model is suggesting. Okay. So how do you do that in terms of machine learning? So basically, you will take your data sources, like I explained. So you have your journey, and then you have the attributes. You combine all that into a single repository. Yeah. And then we split the data, and I'll keep stressing on this: validation. So we split the data into a training set, and we split it into a validation set. Yeah, once you've collected it, then we try 1, 2, 3, 4 different machine learning models on it. So the classification bits. So we see which ones, so we look at different classifiers or different clustering algorithms, and then we see how accurately do they, each of these algorithms, how accurately do they predict that this person is actually going to upsell, this person is going to cross-sell. So depending on your accuracy, you can decide to merge all those models together and come up with what you call an ensemble, which tends to give you a higher prediction. So because maybe in a certain group, one model is able to predict very well, but in another group, another different model is able to predict very well. So if you bring them together, of course, you get a better accuracy and prediction. And then from there, it gives you the propensity scores. So like it tells you, so 11% likelihood of this guy buying, 39% for this guy, 70% for this guy. And of course, this would make sense to target the 70% guy first before you come down to the lower propensities. Yeah. So the models you will use in this case are things like if you have a lot of data, you can use neural networks. If you don't have a lot of data, forget about neural networks, and I'll keep stressing this. You can use random forest, which perform superbly well, even with not so much data. You use support vector machines, and you can use boosted, gradient boosted models, which is basically tree-based models, but just a bit boosted. And again, we can speak about the details if you're interested at a later point, and exactly how each of these models can be done, or we can use it for in this type of data. So yes, so once we have that, then remember I mentioned a recommendation engine, yeah? So you build a model that is able to identify these people. Then the next thing is you have to build a recommender engine. So to say, because basically what you will give to your salespeople and your marketing people is a recommender system, which says if this person is female or between 25 and 35 and, you know, diram, has these kind of attributes, what you do is you're more likely to upsell if you offer them this particular product, or you offer them this package, or you give them this kind of discount. So they like discounts, this particular cohort of people, and you give them this discount, they'll be happy to buy more things. Or if you bundle your products into, say, motor insurance and household insurance, they'll be happy to buy. Or if you name the product like a lady product, lady motor insurance, they'll be happy to buy. So this kind of recommender systems and recommender engines, based on these attributes, how best, and first of all, which products to best serve this customer, and how best to portray that product for them to have a higher likelihood of buying the products. So yeah, so that's basically your upselling and your cross-selling. So the next one we look into is what you call your net promoter score. I hope you're familiar with this, but if you're not, just as a brief, it's commonly used. Any customer service person will tell you this. It's a commonly used thing to track customer satisfaction. Yeah. So it is very important because if your customers have a high NPS, they're likely to recommend your company or your product. Yeah. But if they have a low NPS, they're likely to be very bad detractors. So they're likely to be the guys posting bad things on your social media channels and making other people be scared about coming and buying from you. So this is clearly a very important thing when it comes to customer acquisition and customer retention. But the problem with the NPS score is that you never get high responses. So if you send out a survey, you ask customers to give you feedback, on average, only about 18% of them kind of tend to give you the actual feedback. So it doesn't help you a lot because 18 out of 100%, you're left with 72% of your customers who you don't know where they sit, yeah, with regard to satisfaction with your services or your products. So in comes machine learning to save the day again. So basically, now in this case, what you're trying to do is you learn what kind of NPS scores the customers the 18% of the customers that have responded, how it matches to their profiles. Yeah. So again, you take into account the journey, the user journey, and you take into account the user attributes, and you combine these, and we learn that a person who's had this kind of journey and who has this kind of attributes is likely to recommend to have a high NPS. But if the not, they're likely to have a very low NPS and then be a detractor for your company and your products. So then once we learn that, we use that to the rest, the 72% of the people who did not respond, who did not give you an NPS score. And then it gives you an indication of what is the likely NPS that they could have given had they actually given it. So once you have an idea of that, then you're able to tell who are the people who are not happy. And of course, for retention, you need to target those people. Yeah. So then you can, once you're able to identify that, you can come up with what you call, like you can come up with recommendations on how to make them, change them from a low score to a high score. So maybe offering packages, maybe having the call center calling them and speaking to them to figure out what's going on, why they're not happy, and so on and so forth, and try to change them or turn them into high scorers from the current low scoring. So this is a very crucial thing for many companies, at least here in Europe. I've had to work with it for work on them for quite a bit of time. They're usually very like, especially the sales and marketing teams are usually very curious as to how we're able to tell the scores for the people who do not respond. And this would be a big score for those of you who work in any customer related like retention, acquisition, and this type of thing. It would be very useful for you guys. Yeah, yes, that explains what I've said. Okay, so the last use case is not NPS. I think this is, I misnamed it, but it's basically looking at your call center data. So the text, the emails that you receive through your call centers, the calls that you receive from your customers with the call centers. How can we make better use of this kind of data? Yeah. Now, the good thing is that it tends to be, this data tends to be a lot because, I mean, customers like calling, sending emails, tagging you on social media. So you have a lot of data. So you can use the neural networks, which work very well with this kind of data. But what can we do with it? What do we do with it? So the idea here is that you can do two things. Now, three things basically. Now, the first one is determine what your customers are talking about, because you have different models, you have different topics that your customers will be talking about, and they're kind of set. You can say this customer is unhappy about the product, this customer is talking about pricing, this customer is talking about a breakdown in service. So you have different topics, and I'm sure within your call centers, you have people who handle different topics better than others. So the idea is that if you're able to get an email or get a social media text, and you're able to classify the topic and immediately shoot it to the relevant customer, what do you call customer service agent, who best deals with this type of thing. So automating that process is very important, as opposed to just those things coming into the manager's inbox and then him distributing them, having to look at what is this guy talking about, what is this password, blah, 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 and trying to figure out. You can basically just automate that using models, what you call the topic modeling models. Yeah, it's redundant, but yes, it is what it is. So that's important. The other key thing that you can get from this is sentiment. So you understand what sentiment is, basically trying to figure out if this person happy, sad, or different categories of moods that they can have, yeah? Why is this important? Because a sad person during a call or a text is likely to first of all churn, like it's likely to make the drastic decision to leave your product or your company, or likely to write something bad about your company and this type of thing. So you want to be able to identify if the person is, what the sentiment of the person is through whichever channel they've reached you. So be it a call, be it a text, an email, or social media, you call social media post, you want to see what the sentiment is, and then we just don't want to see what the sentiment is, but we want to change it during the call. So again, you can be able to track, if you get the call scripts, you can be able to track which agents are able to change sentiments during the call. And then you know that if you get a customer who has this particular sentiment at the onset, this is the person that needs to be speaking to, because there's a higher likelihood of them changing their sentiments during the call. And by the end of it, you have a slightly less angry customer than you had at the beginning of the call. So this is again something very important, crucial, and here we work with it quite often, or we work with this, we build these kind of models very often. They're quite popular here. And then the other thing that you can do is from this type of thing is do what you call apply sequential models to learn the paths to success. What do you mean by this? Like saying that for every customer, they come in, they have a starting point. So either they are hungry or they're happy. Or just to make it simple, we use the binary choices, angry or happy. Now, if they're angry, this particular path of actions tends to lead them to being less angry. They may not be necessarily happy, but less angry at the end of the engagement. And this particular path tends to lead them to an even angrier state. And this particular path, different outcomes. Yeah. But the thing is that these outcomes vary depending on also the customer. Like not every customer will take the same journey and be happy at the end of it. So you can, when the engagement is beginning, you can collect the data, and then immediately your call agent or the person who is dealing with them is able to be notified immediately like which step is best suited for this particular person. So we kind of custom it to the individual. Yeah. And this way you're able to come up with much better customer service. How do you call it, protocols? I don't know a better word for it. So this kind of thing, yeah. That's what we call the paths to success, where you want to retain the customer and make them happier if they're not happy, and this type of thing. Yeah. So basically, the idea here is once you have all these things, of course, you implement them through your call centers, and you're able to utilize your what do you call it, like your call center resources much more efficiently. You're able to reduce the time that it takes to respond to your customers, and most importantly, you're able to evoke the right kind of sentiment and the right kind of reactions from your customers who would have been detractors, and now they're kind of turned to be promoters for your company or for your products. Yeah. Yes. So basically, that brings me to the end of this particular session. So the option is that depending on what has drawn your interest, if you're still there, then depending on the responses, we can see which one to go into deeper in the next session. Yeah. So that's it for now. I guess there's a question and answer session from here. Thank you, Susan. It's nice to see that you're still there.
Yeah. All right. Thank you, Keldin. That was very insightful. Yeah, I'm sure you've been able to pick a couple of things. So back to the class. I think, Keldin, you can pay attention to the chat box there. Yeah.
Okay.
Some guys.
I'll look at the chat.
Yeah. So the floor is open for any questions.
Yeah. So you can ask questions. You don't have to limit them to this particular presentation. If it's something, of course, machine learning related, I'm happy to answer.
Yeah.
Okay, I see someone says they're looking forward to, that's Rodney, looking forward to practical learning on upsell, cross-sell, and retention. Yeah, it's quite an interesting field for me as well. I'm really enjoying working in this particular area.
Mm-hmm.
I'm waiting for your questions, guys. Or do you not have questions? There's no stupid question, by the way.
Yeah. maybe as
So Marcy is asking, how can you measure customer satisfaction where you provide service? Now, usually the thing for customer satisfaction is that, and that's what I was talking about, the NPS score. You basically give them a survey after the provision of the service, and of course you keep it simple to kind of tell you what they thought about the service. So were they happy with it, or they not happy with it? Just kind of keep it simple, yeah. Not too many questions, because then they'll run away and not answer your thing. And once they give you this, because not everybody will answer, then you can use the data, the attributes of these people who answered, and infer the same on everybody else on your books, and see how would they be happy with the service, or how would they be not happy with the service, and this type of thing. And then you can take further action depending on what you deem best for this particular scenario. I hope that answers your questions. Then you have Teresia says, must you create models, or can you use pre-existing models? Now, Teresia, of course, using pre-existing models is always a good thing, because it saves you a lot of time. Now, the problem with using existing models is that they usually custom, because your model is as good as the data that you use. Yeah. So if you have no view of what data was used to make this model, if you don't have this understanding, then I would not be too quick to implement an existing model. Yeah. I give you a simple case, something like sentiment analysis. Everybody, like ranging from Google, Facebook, Amazon, IBM, all these people have sentiment classifiers, yeah? But they usually train these things on the English language. Now, if you take it to your Kenyan scenario, we have people here mixing Swahili, some of us tunaongea Kiswahili, wengine tunaongea Kijaluo. And so when you throw these words to this classifier, it's not able to identify what this person is saying, or what the sentiments of this person are correctly, yeah? So that's why I usually insist that in the cases where you have your own data, it's better to train a model on that particular data, as opposed to using a different model, like a model that has been trained before. But if you do not have your own data, and you do not have the capacities to do the training for yourself, then all you need to do is understand what the pre-trained model was trained on, and see if it's applicable to your particular situation. And if you're confident about this, then you can go ahead and use it. So those are my thoughts when it comes to pre-existing models. Then you have Dennis Irimo. Hi, Keldin, really good slides. Thank you. So you said most of your time is spent cleaning data. What is the best software or algorithm to clean data? Dennis, the thing with software is that software is just a tool. Yeah. So you can use any software. I mean, you can be an R person, or you can be a Python person like myself, or you can be into Ruby, all these different forms. There's so many of them. Yeah. So basically, when you're cleaning data, you use whatever you're comfortable with, and then you don't necessarily have models, like you don't have packages for cleaning data or algorithms for cleaning data, because the data cleaning process will be very varied depending on how your data is. So it's very difficult to standardize this into an algorithm. Yeah. So basically, what you tend to do is you get your data, you put them into one place, you load it into your models, and then you start exploring the data to see what kind of cleaning is required. So if, say, there are missing entries, we get rid of those missing entries. If, say, you have text in some places where you're supposed to have numbers, then you act accordingly. You have, I don't know, like there's so many different things that you need to do to clean depending on your situation. So in a nutshell, use whatever software you're comfortable with. Personally, for me, it's Python, but I can also work with R, because some companies insist on this particular kind of thing. And from there, just explore your data and see what kind of thrashing it will need, what kind of panel beating is necessary for your particular data set. So the next one, So Rodney is asking, please talk a little on this, on if this can be implemented to predict premium defaulters. Oh yes, definitely. I have worked on a premium default sort of thing for one of the companies in Kenya. Basically, what you will be doing when you're talking about premium defaulting is you're looking for a probability score. So if you've defaulted, say you give a label of 1, and if you have not defaulted, you give a label of 0. Yeah. Of course, for a particular year, yeah, because you cannot take the whole book. So you take a particular period of time and then you look at who were the defaulters over this cover period. And then given that, now you will train a model that outputs for you a probability score of the likelihood of being 1, so being a defaulter. So this is basically something like logistic regression, or you can use your decision trees or your random forests. And then once you have the weights for the particular model, then you can apply it on now your current book. You can apply on your current book and kind of see, or not even just in the book, or even a customer that's coming on board that for the first time, you can just apply it on them and see what is the likelihood of this person paying the full premium. You guys are familiar with fintech. Fintech is a big thing right now in Kenya. And when they talk about credit scores, this is a similar thing that they're doing. Yeah. So they're just predicting how well you'll be able to pay your stuff, pay your loans. So those who run away with the policers, they can detect you after some time, and then you will not be able to get any loans from these guys. So I hope that answers that. So you have Susan asking for insurance. The prices are standard for each product. Have you have the data where the variations of pricing have hazard discounts? How easy to train the data? So Susan, currently, I hope I've read the question out loud for everyone to hear. Tim, if you don't hear, just let me know on their behalf. So currently, and unfortunately, the case in Kenya is that prices are predetermined. Yeah. But I'll tell you this is not going to be the case for long, because as we speak, the couple of one or two insurance companies are in talks to kind of have a risk-based pricing approach where you price based on your attributes. And for the actuaries in the room, you'll understand that the price is basically your probability of default or probability of risk times the value at risk, yeah, and you combine the two and discount them to the present time. So when you're doing if you're using machine learning, what you'll be training your different models. So you'll be training a different model on the probability score, which will be similar to the credit risk scoring, which will be similar to the premium default scoring that we've just spoken about, yeah. So similar models. And then you train a different model, and this time around a regressor, to give you the value at risk. So given a car, this guy who's 25 years old and he's male, he's not married, he has no children, he drives a Subaru, and the Subaru is blue, and it has an STI label on it. So the chances of damage are quite high. And then when it happens, that machine is expensive. So it gives you the value at risk, which is not necessarily the full value of the car. It is a value that you're most likely to have to pay to repair the car or replace the car. So once you train these two individual models on these things, then we use the outputs of the two to come up with the risk price. So you just multiplication of the two and then discount it to the present time, assuming it happens roughly uniformly distributed over the year, over the cover period. You discount it to the present time and you get your risk price. Then you can do your profit loadings or your commission loadings from there on. How easy is it to do? It is very easy to do. It is not a difficult thing to do. But the difficult task will be cleaning your data, because I'm sure the data that will come from your CRM will be shocking, if anything, yeah. So yeah, the models themselves are not difficult to fit, but the cleaning part, the cleaning up your data and being confident with what your data says is going to be the biggest headache.
So Kelvin,
Okay,
maybe
so
I can just add.
yeah.
I could add just to Susan's question. There's a particular model which is used for Hafasad data, the autoregressive moving average, which is always deployed when you're looking at data that fluctuates. For example, weather data. Yeah, so it's really possible. And as you said, it's important to know the type of data before you choose the model that you're going to use.
Yeah. And in this case, if it's fluctuating with time, it's basically a sequential problem. Yeah. So the moment you have a sequential problem, you use the team says one of the sequential models is ARIMA. Yeah. So the moving average data, moving average model. And you can also use things like, I'm sure you've heard of these things, these neural networks called, what do you call them? These are for natural language processing team. What are they called? At the end of the day, I'm very tired.
NLKT?
These like LSTM, yeah? So you can use the LSTMs for this sequential type of problems, yeah? Okay, so I'll go to the next question. Thank you for the presentation. Have you used machine learning in other areas like academics, research, and health sector? I'm not sure what you mean in academics and research, but if you mean publishing, yes, I have. I'm currently in the process of publishing 2 papers.
Kelly, maybe I can give you Kelly, could
Yes.
give you a context. So Alex is a PhD holder in pharmacy, so he's involved in research, in pharmaceutical studies.
Yeah.
And in your opening slide, so you had something on genomics, yeah? Perhaps something you might want to or explain to him.
Okay, I'm happy to explain that to you, Alex. You can get my contacts and then we can talk about if it's publishing, you mean. But I may not be necessarily be an expert in all areas, yeah? So I'm not an expert in the field of chemistry. But yeah, but you can, the principles are the same, so we can discuss the principles. Yeah.
And maybe in your area of insurance, health insurance specifically.
Yeah, health insurance. I can give you good overview of that and the things that can be done there and which are being done there currently. Okay. There's another person typing. A couple of people typing. Let's see how much time do we have, Tim?
So we have about 5 minutes. About just 5 minutes, then we can a little bit.
Okay, so you can see someone typing. Thank you, Mercy. Wait, is this Mercy the one you're with at Britain?
Oh,
are you the one?
No,
Mercy?
This is a different one.
Okay,
she's on a from a finance background.
Okay. So Mercy is asking how long for the masters in Germany? Okay, so the masters in Germany is too long. It takes 2 years. It's 4 semesters. Basically, you have 3 semesters of intense coursework and practical work, and then you have a semester of writing a master's thesis. So it's too long, but it's been a game changer for me. It has really opened because I had the practical aspect of things, but then the theoretical understanding of things was lacking to some extent, which is now kind of nailed in, and which helps in when you come across problems which are kind of unique in their own ways, and you need to think from first principles to be able to apply a solution to it. This is where having a theoretical understanding of the models, what the models do, becomes very, very nice. And especially when you don't, you have many, what do you call them, libraries and packages nowadays for machine learning. But sometimes you come into scenarios where the person who made wrote the library did not envision this particular kind of problem. So what you need to do is take the code and then custom it. So you fork the code from GitHub or whatever it is, put the code, and then you custom it to your particular situation. The only way for you to do that if you understand the theoretical aspect of what is happening. Yeah. So it is too long, but it is completely worth it, I would say. But I mean, you have other shorter options nowadays which you can take. You have Coursera, which has nice courses. You have a good coach team who's also doing quite an impressive thing back there. And very soon I'll be coming back home. I hope to come back home soon, and also maybe I'll start teaching with the team and take the theoretical part of it for those who would be interested. Because I've gathered a lot of knowledge here, which I feel can be benefit a lot if it's shared. There's no point for it sticking in my head only.
Yeah, that's the spirit.
Yeah.
So we're glad you're already doing it with this cohort. So
Yeah.
it's something that we see how to build up synergies. Okay. Yeah, so perhaps we can I can see Patrick is typing. Patrick had not asked any question before. Okay, let's wait to see what she has to say. Okay, his question has not shown up.
Okay.
But we can, yeah. So I think Kelvin, I very much wish to appreciate your time, your knowledge, and then your insights and your patience as we worked around this first session. I think the idea is to build up this. We're going to open it up, and I'm sure building such kind of synergies, as you can see, we can be able to enable the community around embrace the adoption of these tools and skills. I can see Patrick's questions there. You want to take it?
Is there a link between machine learning and artificial intelligence? Patrick, these are very similar things. Machine learning and artificial intelligence are quite similar. One is just a subset of the other. So artificial intelligence is kind of like the big circle, and then machine learning is a small circle being artificial intelligence. So what people mean when they talk about artificial intelligence is basically a combination of different algorithms that can make different decisions. So, when you're training a model, you train it to do a particular task. So you train a model to check whether the thing in the picture is a dog or a cat or a person or another car. Yeah. So that's the only thing that it does. So if you want something else that decides to brake the car on how much brakes to apply, then you train another particular model to do that particular thing. Now, when you combine these together and other different decision making models together, that's what now people will call artificial intelligence. Because now it can make different decisions on its own, and one decision can feed into the other. So when it sees a person next to it, like when a self-driving car sees a person, then it's able to communicate to the brake decision algorithm to decide how fast and how much to apply the pressure on the brakes. And then once the brake has done its job, then it talks to the accelerator and tells them, okay, now you can accelerate this much. So the decisions are being able to be transferred across, and then just basically how our brains work. Yeah. So we receive something, and then we can be able to make judgment and talk to something else. So that's what we call artificial intelligence. But then now the different algorithms are trained via machine learning. Yeah. So that would be the link and the difference.
Yeah. Cool. Okay. Thanks, Kelvin. Any other question?
So, Tim, I would suggest this to be able to maybe prepare well for the next session. You can maybe gather information on which parts exactly they would like to go deeper into, and to what extent.
Yeah.
And then kind of get a sense of whether we will look at the models themselves, or. But I mean, I'm not be able to share data, so this will be dependent on what data they have.
Yeah.
But we can look into it further depending on what the feedback will be.
Yeah.
But for this, I will need a bit of like if you can decide quite early on, so I'm able to have enough time to prepare.
Cool. Yeah. So I think it's a good thing you're on the WhatsApp group, so we can take that conversation as a continuous conversation on the group as you help prepare for the next session.
Okay.
Yeah.
So guys, you can already start the conversation there. Yeah.
Yeah. Sure. Yeah, I really like to appreciate again, Keldin, your time. And I know, what time is it there?
It's 8 o'clock now. Actually, I need to go because I'm still in the office. I need to leave the office
We just
and go have some food.
1 hour.
Yeah, it's just a 1 hour difference.
Yeah.
Yeah.
Thanks a lot for your time. And I wish the rest of the class all the best as we prepare for our session. So just to confirm, we'll have the class on Saturday, and I look forward to you sharing. I'm off to Addis tomorrow, but you're going to be with Derek on this coming Saturday. So we'll share the details on WhatsApp,